Afternoon. Thank you for joining us today for Quest Forum Digital Event Innovation Week. You've joined us for Make JDE Edwards Elastic with Containers and Auto Scaling, presented by John Bassett and Todd Burton with GSI. Before I pass it over to them, I want to let you guys know all phone lines are muted, but if you have any questions, feel free to drop them through the question module. We'll spend some time at the end answering any of those questions that have come through. Also want to let you guys know we are recording this session and we'll be posting it to a Go to Stage site post this, as well as the Quest website for y'all to have access to it. Saw a few more folks join, so I want to let everybody know all phone lines are muted. But if you have any questions, feel free to drop them through the question module and we'll spend some time at the end answering any of those questions that have come through. So at this point in time, I'm going to turn it over to John Bassett with GSI for Make JDE Edwards Elastic with Containers and Auto Scaling.
Hi, everyone. Welcome to today's webcast. It's unfortunate that we can't be all face-to-face, but, obviously Quest figured some good stuff out here. My name's John Bassett. I'm Executive VP and Chief Technology Officer with GSI. I head up a lot of things at GSI, including our cloud cyber practices, and as well as assist Todd with our managed services group. Joining me today, and your main presenter is Todd Burton. Todd is the Director of Managed Services. He's also the guy that has been spending a lot of time working and setting up containers with JDE Edwards. As such, he manages some of our DevOps team, our automation tools, our Genius monitoring solution, as well as the guy that handles almost everything ServiceNow in terms of usage with our clients. So here's our safe harbor statement, basically saying, a lot of the stuff here is copyrighted GSI, and the drill. Okay, so the big question is what is containerization, and why would it be of benefit to your company? And I'm going to start with a little history of containerization, and then Todd's going to go into detail exactly what it is and how it would be of benefit to you. It's nothing new. Containers have been around for a long time. However, the use of containers in a usable fashion has taken some time to develop. And here's a little history. I mean, containers have been around since the late 70s, early 80s, but a little history of how JDE Edwards has used the technology. And as most of you are aware, Enterprise One is an on-premise type of software solution. A lot of people have made it cloud-like over the last few years by using virtualization and cloud technologies. In 2000 and around the early 2005s, it was just completely hard architecture. You needed a machine to use it. You had to buy a PC, but then Citrix came along and you could do multi-user. Then the web technology came along, but still all physical servers, just in a more shared environment. Around 2010 timeframe, we started seeing VMware and Hyper-V solutions work, but still on-prem, but it allows you to a lot more management, better use of your equipment, a little lower cost than buying every machine for every purpose. 2013, key date, Docker debuted to the public. Docker is the solution that we'll be talking about today. It is the solution that we've been able to make work with JDE Edwards. But JDE Edwards we didn't really get on the bandwagon. There were some couple of companies that made some early attempts at making it work, and it did work. But around the same time, cloud virtual servers started appearing. So we were busy migrating to Azure, busy migrating to OCI, et cetera. Now, the containerization has become more widely used in other applications, databases, other ERP software. So the question is can we do it with containerization? And the answer is yes, we can. And as things start progressing, we're going to find that this is a cost-saving and maintenance-saving solution for you. So basically, the containerization is going to allow you for a smaller compute footprint and also help you reduce your support costs on projects and maintenance. So at this time, I'm going to turn this over to Todd Burton to speak. He's going to talk about who will benefit from it. What does containerization look like? What would the map look like for you, and whether you'd be a benefit? Todd, welcome to today's session.
Thanks, John. And as John said, the technology's been out there. It was used in a lot smaller and development role, and now, especially with the cloud technologies, it's kind of all come together. Throughout the rest of this presentation, we'll go into details of some of these, but right up front, there are aspects that benefit every type of company. The self-healing and portability, offline DR, ease of rollback. Every client their system can benefit from that. You get into medium-sized companies where they're using, Enterprise One overnight, running all their scheduled jobs and everything, and maybe 2 shifts during the day. They lose that window of opportunity to do maintenance and things like that. So they start to see additional benefits, including scalability because of the volume of users, real-time deployments, and reduced system administration. Then you look at a large company that maybe has a global footprint, and they're in all the different regions around the U.S., and they really need their ERP system to be online 24/7, 365. So then you're starting to look at the benefits where there's nearly zero downtime. You can do offline patching and maintenance and keep your production system up and running with this technology. There are aspects to this that will benefit every company out there running JD Edwards, in our opinion. And John, if you want to flip to the next slide, we'll start getting into details. Right up front, we want to compare how containers differ from virtual machines. VMs have been out there for quite a few years now, and most people are comfortable and with their understanding, and they're widely used. It was a great technology to be able to run multiple servers in one physical box. As John alluded to earlier, it created a smaller footprint. But with it, you still have the complexity, especially around the operating systems. With the image on the left is the VM server, and that host, you've got the base operating system. Well, then for every virtual machine, you have another operating system. And that, just with configuration and keeping them in sync, setting-wise and patch levels, that's a big undertaking. And you also look at the fact that each one is requiring its own resources. So in general, you look at an OS needs 2 gig of RAM, X amount of CPU, and 80 to 100 gig of hard drive space. On the left with VMs, you've already eaten up a great portion of that host just with the operating system. Containers takes those additional operating systems out of the mix. It actually contains the application to sit alongside other applications on the one operating system. And it passes through and uses directly to the hardware a lot cleaner. So ease of support, you only have one operating system to patch and deal with, ensure it's configured correctly, and it allows it to be a lot more lightweight on the compute space and drive space. Already, you're able to use much less resources. So go ahead and flip to the next one, John. Now we're going to get into the section covering compute savings. And these are a couple different ways besides what you're saving on the operating system that Docker can take advantage of. Next slide. So currently, you have to build out your ERP system to handle peak loads. Typically, Monday through Friday, you're going to have your peak time. Some clients, it's 2 hours. Some clients that, it could be 8 to 10 hour peak. But there are times that systems are sitting idle. Say you have 800 named or concurrent users in your web layer. You essentially need, without even considering fail safes and extra protection, at least 9 web servers per JAS instances. Well, overnight, if you have a workload of 80 concurrent users, 90% of those web servers are not being utilized. They're just sitting there and you're still paying for them. And when you look at the amount of downtime for an average system, you've got evenings, which are a lighter load, weekends, which are light or empty, late night, overnight, holidays. When you observe a holiday and your company's closed, you're still paying for that system designed to handle your peak loads. The other aspect is expanding your system in today's current technology. If you bring on 100 new users or open up a new division and add them into your ERP system, now you've got to look at analyzing, do you need more web servers? Do you need additional logic servers to handle the loads? Planning it out and the expense and cost of spinning that up is something that has to take extreme consideration. John, go ahead to the next. Thank you. So how we address that with containerization is it is designed to automatically scale based on your needs. So the diagram here is kind of a visual representation of your containers with the nodes being the server. The green containers are your base. You have a batch, a logic, and your web containers. Those are always on. They'll be up and running so that at any time somebody can use the system, or your batch jobs are running for your scheduler. The blue ones are the cloning technology that comes with Docker. It allows your web server to be configured based on CPU and RAM loads for that container. If it exceeds your threshold that you set, say 80 users, it triggers spinning up a clone of that server to handle additional users. And it will continue expanding and even work with a cloud infrastructure or wherever you have it placed to spin up additional infrastructure nodes so that it will grow, and those nodes get added to the Docker swarm as they spin up, and it knows it has more room to allocate additional clones. And all of this is completely configurable. You could scale a node to handle 6 clones if you have a much larger footprint and cloning is happening more often. So back to the web layer, now you have right here 4 web instances or 4 web containers, say 2 production instances each. This can handle 800 users. But again, on the weekend, you're not going to need node 3 and 4, so they declone the containers automatically, and then the nodes go offline. You're not paying for that computing power when you're not using it. And right now we have the logic server and the web technologies able to clone and declone as the workload grows and shrinks. And it really helps save the money as you're only paying for the infrastructure that is needed at any given time. All right, let's move to the next slide, please. So that shows your production system growing and shrinking as your workloads. We also look at the ability to use this technology for non-production systems. There you have, potentially 0 users a majority of the time on fat clients and your non-prod environments. And scheduling those to be offline and not paying for that infrastructure when it's not in use, again, is going to create additional savings. If you look at your non-production system today, it's always on. It's a smaller footprint than production typically, but it's always on and running. If you drop that down to a 12 by 5 schedule, say 7 a.m. to 7 p.m. Monday through Friday, your savings on your cloud infrastructure could be reduced around 57, 58%. You drop that scheduled online time down to a 9 by 5 schedule, you're talking nearly 65% savings on that non-production hardware in a cloud environment. You may want to do a custom where you go in and add your holidays and maybe Fridays 4 p.m. instead of 7 p.m. You know, that's all customizable and configurable depending on what that system actually gets used. You're also looking at additional savings of less alerting, less troubleshooting, because those systems are offline. They're sleeping. They're not going to be alerting and annoying anybody and causing additional work on those off hours. The workstation is another huge savings, and this one gets even larger when you look at installing packages. If you have a system with 30 workstations, rolling out a new full build to all 30 of those workstations is a very time-consuming effort. Later on, we'll go into details on how, but with this technology, you're able to install one FAT client and be done with it. You don't have to do 30. Consistent configurations. A lot of times we see clients, we get in with them and, oh yeah, we have 6 workstations, but workstation 3, you can't log into dev, and there's a problem with workstation 5. You know, it's troubleshooting and trying to fix those or reinstall them. With Docker, you have an image, you just spin up a new copy, and it's always consistently configured. Somebody didn't leave debug mode on to fill up the hard drive. So your support costs come down dramatically at the workstation layer. Windows licensing. You don't have a Windows license per container, it's per node. So there's additional savings there for the workstations. All right, let's move on to the next slide, please. Now we're going to get into reduced downtime. This section here is how we're going to utilize Docker technology to try and hit 0 downtime, but at least near 0 we think is very achievable. Next slide, John. Thank you. So offline maintenance and patching. Maintenance and patching is a necessary evil of the computing world. You look at security patches, they come out pretty much on a monthly basis. And in this day and age, you want to stay current on security patches. So that generally means monthly, you're bringing your system offline, kicking all your users out, and having that window to do patching. With Docker, we're able to do that offline and not take production down. The memory leaks, you know, some are quarterly restarts. Typically we see monthly. Some even do it weekly, and at the web layer, daily we've seen. Now we've seen that daily restarts, you know, trending away. But still, if you're talking once a month, once a week, restarting your entire system, that brings risk into it. You have to kick your users out. If you're a 24 by 7 shop, you can't afford that downtime. Your employees aren't able to do their job. Package builds. When you do a build in production, that's putting a load on those production servers. And typically it's not felt, or you do it off hours in a lighter window, but there is still that load and potential risk to impacting users. Package deployments are even greater. You have system locks to ensure it's able to deploy cleanly and safely, and that can impact users that are running on the system. You know, and then you look at the other supporting technologies, the operating system, the Java runtime, web application. Those all require updates and patching also, which in today's day and age requires downtime. Let's move to the next slide. So how do we achieve this with Docker? The nice thing about Docker is the containers are based off images. So you design and create these images that spin up, and when they're running, they're the container. And even a clone kicking up will go from the image library and use the most recent image that's configured to be allowed. So how we're able to do the patching and maintenance offline is we spin up a utility node, so an additional server, and it's not interfering with production, but it's essentially a copy of it. And we're able to do our package builds or patching WebLogic and do all that offline on the utility node and have no impact to the user base. And then we save out a new version of that image to the image library. So say we update the web container with a new version of WebLogic and get some security patching in there, and we save off that new version of that image. Then we go into Docker and configure it to use it and set it up as now the desired state is this web version. And it will automatically spin up that new version and dynamically port all the new users and connections over to that new copy. And once it's migrated all the connections over, it will declone or despin, or despawn, I suppose would be more accurate, that old version of the web container. And so your users aren't all told to get out of the system and log back in, or get out for 15, 30 minutes and come back in after lunch. They continue doing their job seamlessly, and the system's up and still running. There's also rollback. You can set a threshold when you're spinning up a new desired state. You can set a threshold of failure rate, so that if it starts spinning up the new container in the production nodes, if it doesn't come online correctly or cleanly, it'll automatically, dynamically roll it back to the last known good. And then we go back to the utility server and troubleshoot and figure out what the issue was. And you can also manually roll back. Some changes Docker wouldn't be knowledgeable about. Say you pushed out an ESU and a user reports back the issue. You can still go in and manually configure it to roll back to the last known good. Again, you don't have to kick the users out. Say the ESU only affected one department on your system. You notify them that we're rolling that back, let them know when it's done, they can continue working. The rest of your employees are not affected. They're still doing their day-to-day job. So it helps really keep your employees doing what they're paid to do, is their job, and taking the interference and downtime of the technology out of their way. All right, John, if we can move to the next slide, please. Now we're getting into healing and additional benefits that Docker can provide. Let's go to the next slide. So Docker has its own built-in networking and is very configurable. It is very smart and dynamic right out of the box. But there's multiple modes. You can, configure 2 Docker swarms to chat with each other. That's how we're able to create an isolated utility node that doesn't affect the production systems, with copies of the same name servers up and online running. And the dynamic load balancing is very unique to Docker Swarm. There are other container technologies out there that take over managing the containers. But one thing that Docker Swarm offers that is very, very useful when it comes to the cloning technology is dynamic load balancing. Right now, in today's technology, if we were to spin up a new web server, now we have to go to the load balancer and configure it to know it's there. When Docker clones a web instance, it automatically knows to update its network layer to handle it. If somebody hits, port 80 for production Jazz instance, you can hit any IP on that Docker swarm, and it will know to direct it to the least used web server because that port is what's being used. You can configure their networks and tune them. Another huge feature that comes with Docker is health versus unhealthy container flags. And that's how it does the automatic dynamic rollback when it's rolling out a clone or a new desired state. It's how we use the RAM and CPU utilization to identify the need for an additional clone to spin up. Or the inverse, it monitors the RAM and CPU utilization to identify, based on the threshold set of all users logged out, it can now declone that clone so it's not taking up any space. We are currently working with our Genius monitoring tool to integrate and make that Docker healthy, unhealthy feature a lot more intelligent. With our Genius monitoring, we monitor inside JD Edwards to a large degree, and we're tying that into the Docker technology. So in essence, you'd be able to set a threshold for, say, a logic server and say, I want to set 12 or 20 zombies on this container. It means it's unhealthy, and flag it as unhealthy, so that Docker will spin up a copy, migrate all the connections over, and then despawn the unhealthy one. And again, it's to be less obtrusive to your employees, because a few zombies on a system, it will affect a handful of users, but it won't necessarily affect, 80 or 100 people connected to that server. So why interfere with them when it can just take care of itself? All right, let's go ahead and move to the next slide, John. Thank you. Some additional features and benefits that we get with this technology is the transportable disaster recovery. As you saw on the previous slides, there's an image library. It's essentially a snapshot of your desired system, and that's offline. That's in a remote location, so that, in a worst case scenario, we're able to spin that up on any cloud solution, or if we needed, a physical local solution. And it just takes installing, Docker, which is a 15, 20-minute process, and then running the scripts to bring your system online in a separate location. So you don't need to have a system up and idle and paying for it for your DR. There is the possibility to utilize this as an offline DR library, essentially, that can be spun up in a matter of minutes. Then it would just be bringing over your backup of your production data, and you're online probably within a couple hours, depending on the platform and the solutions. Affordable migrations. Today, in our current technology, to lift and shift between a cloud provider, say you get in a good deal, you set up with a cloud provider with your ERP system years back, but over that time, your company has taken a direction with a different cloud provider, and they're very happy with that, and you're looking to migrate to that other provider. Right now, you're looking at months to move over and re-architect your system on another solution. With the container technology, you're talking days, and most of that is going to be reviewing if you want to re-architect or redesign, edit the script to bring up your containers in the configuration you want. The time savings and overhead of that type of project is a huge cost savings, and it provides a lot more flexibility with your ERP system. The other huge advantage that we see to this is lab environments. If you take the offline utility server and expand on that, within an hour or two, we could spin up a complete copy of your production system for, say, Genesis load testing. And it's a copy. You're not going to be testing against production data, creating new records, or editing your production data. It's an offline copy that you can just throw away when you're done. But you could set it up and plan a 2-week load testing session or offline code current project. The ability to quickly, easily bring up a copy of production and test anything, and then just despawn it and come away with that knowledge before you go do something in your current production. It makes things a lot more flexible. Again, today's day and age, a project like that to spin up a copy of production is weeks, not hours. All right, John, if you can move to the next slide, please. A couple notes around containers. It is very new to JD Edwards. A lot of folks have been using it in labs. I know Oracle, we've been talks with them closely. They've been utilizing it in their lab environments. Just recently, 2 weeks now, Tools 9243 came out. That is a requirement for Server Manager to see and manage clones. Within Docker, as you saw in the previous slide, the .1, .2, that is how Docker identifies clones. Server Manager now has that technology with the latest tools release to talk to those clones as if they're regular instances, so that you can get full reporting. That was a key tools release we were really waiting for. There is still support for batch server cloning. They're working on it, and they're planning to release a Q4 tools release where you will be able to clone batch servers. The gotcha with that is the single-threaded job queues. If you clone it, now it's not single-threaded anymore. So it is around the corner. They're working on it, and there will be a virtual queue system that will allow for batch servers to be cloned also. But we can still take advantage of it today with JD Edwards. And for the batch server right now, we just flag that container as not clonable. So it's nothing that it might try to clone. You just define that. All right, let's go to the next slide. Thank you, John. So just a quick summary here. It's the future of technology. Personally, I feel containerization is going to do to the computing world what both VMware and the cloud technologies have done. Our goal is to make IT on, it shouldn't be a huge overhead. It shouldn't be a big problem or a big impact. Most companies that run JD Edwards, they build other things. They do other things. They shouldn't be spending a large portion of their profits in technology, babysitting it and managing it. And every direction we've been going over the past 20 years is to keep technology there, but keep the overhead lighter. Make it just inherently work. The reduced overhead, the computing costs, paying for the systems designed to handle your peak hour of a week and always paying for that is crazy. If we can bring that down and reduce the cost, it's already a win. The elastic scaling, whether it's your overnight work, your load compared to your daytime load, or it's growing your business, taking on, if you buy out another company, merge them in, you're talking maybe 80 to 300 new users. Are those costs considered on the impact of your system? And growing that out and the project it would take to expand your system, where with this technology, it will just expand on its own and it'll handle that load and save you the time and energy and money to redesign and rebuild your system. The near zero downtime, again, the goal is for your employees to do their job working on the system, not working around downtime and maintenance windows. Let them do what they're paid to do and get their job done. The self-healing, the savings around troubleshooting and downtime, being able to dynamically roll back the last known good quick and easily and not impact all your employees. Being able to have consistent fact lines. Every morning when people log in and work on their workstation, they know they're getting what they walked away from yesterday, a good, clean image. The trade-off, they will have to ensure they're checking in their code nightly, which is best practice and should be adhered to on a daily basis anyhow. But we really see containerization not bringing one or two things to the table. It's bringing a lot to the table. And John, next slide. I think this wraps it up or close. Oh, yes. With this, we are offering, I think it's about a month till May 15th, architecture reviews at a discount, where we will come in and review, your MTRs and your overall JDE architecture, and also review it for how containerization might benefit your system. Definitely some systems will have greater benefits than others, but we are offering this out there so that we can come. Every system's unique, as everybody in this field knows with JD Edwards. As soon as you install it, it's unique to you. So there are different ways to take advantage of this technology, and we'd like to, work with you to review what that potential is. All right, John, next one. All right, this is the Q&A.
All right. We need to bring.
All right. And, oh, sorry.
Yeah, we need to bring Christina back to help out.
All right. The first question is, does Docker work only with Linux, and does it support Windows?
It does work both with Linux and Windows currently. We have been playing, our current system that we have up and running is Linux and OCI. I have started bringing up a Windows-based one, but the technology is there for both Windows and Linux.
Oh, great. Thank you very much. How do you containerize a dev workstation that requires Windows GUI?
With the Docker for Windows, the GUI, it's Docker for Windows can handle containerizing those.
Perfect. And how do you monitor and manage JDE Docker?
Docker is interesting question. So Server Manager is still monitoring JDE, whether it's Dockered or not. That may have come before the tools slide. Docker is fully REST capable. We are working to tie it in with our Genius monitoring. Both are very REST enabled or capable tools. So we're working to integrate those two so that we would be able to monitor Docker as well as the containers and everything like we do at JDE within Genius currently.
That does require you to be on the 9243 tools release, or should say Server Manager pieces of it, because of the multiple containers. You spin up a clone of an enterprise server. Well, to that container, it has the same name. Well, which one is being managed? The last one up, et cetera. But the latest tools release accommodates that.
Right. Before that, it would just, every JDE web server that spun up, it would re-register, and Server Manager would only see the most recent one. So this tools release was a huge help on that side.
Awesome, thank you. Let's see, one other question came through is when the instances are scaled up and cloned using Docker, how are those server definitions created in JD Edwards?
Well, we've got, as far as for the container, the script will spin up based off the CPU and RAM utilization currently. When it hits the threshold that it knows it needs another copy or a clone, it grabs or kicks off a script to bring up, say, JDE Web. It grabs that image and brings up JDE Web.1. And in that, it runs a script to re-register the server manager agent, so the server manager is aware of it and knows how to communicate. And it also kicks off the script internally to self-monitor that instance or that container to know when it needs to clone again. And if there isn't a node available, it gets into terraforming technology, which integrates, depending on the cloud provider, with that admin tool. So you have like a node saved master. That this is what the node should look like in a saved off copy. It spins up and it automatically joins the swarm once it spins up. Hoping that answered that question.
2 points on that, Todd. First, it's not really Docker that's handling the multiple nodes. It's the Docker swarm, and currently Kubernetes is not something that works with this just yet. It may in the near future, but right now, not only not certain, it just doesn't work. The second point, I think the question was, is how do you handle the fact that you have like JDE ent, JDE ent.1, JDE ent.2? How would the mappings work? How would you know which, if you sign in and you're getting a business function mapped, how would you know which one, or does it matter?
So yeah, Docker networking handles that. It knows that anybody looking or request hitting the network looking for JDE logic, say for business functions, Docker knows there could be, JDE logic, JDE logic.1, JDE logic.2. So it's the logic server with 2 clones. And it has the built-in load balancing to send you to the correct container, the lowest utilized container, and it maintains that communication until there's a new unique connection requested.
Great, thank you guys very much. John and Todd, I don't see any other questions, but didn't know if you guys had any last minute tips or tricks for anybody before we sign off.
Quick note, the question or the talk about Linux and Windows. Right now, from our understanding, we haven't tried it, but from what we've researched, you wouldn't be able to take a Linux container and run it on a Docker for Windows swarm. So those would have to be designed and configured based on the platform it's going on. But we're building out a library of, base images essentially that are containered, or base container images for each tools release that we go in and tweak, give, a base name. But an example, so we have JDE ent as our enterprise server saved image. In the configuration for Docker Swarm, we spin up that one image as JDE batch for batch server and JDE logic for logic server. The OCMs are essentially the only difference, and that's all stored within the database. So that base image doesn't need to be unique in that situation. There may be some where we need to create a copy of a unique setting, but it's modifying the changes and then creating a new version of the image.
I have one last thought too. That's around images coming out of Oracle, because we talked to them about it. It's like, hey, should we be developing this? Are you going to be? And I'm not going to speak too much on their behalf, but as of right now, we were told that every client of JD Edwards client is different. Therefore, it's very difficult for Oracle to push out containers for JD Edwards tools releases, ESUs, et cetera, like that. So they'll have a that could change, but as of right now, the support companies like GSI are the ones that can help you get it set up, maintain it yourself, but you're still going to have to maintain your base templates, downloading ESUs, testing tools releases. So there's still some future benefits to be gained, but short term, I think administration and scalability are some keys.
Awesome. Well, thank you.
That's all I got.
Well, thank you all for taking the time to present with us and pivoting with us to this digital event. For the attendees that are on the phone, thank you guys for joining us. We'll be sending out the information of how to access the recording and the follow-ups in it. Again, thank you to the GSI team for participating with us, and we hope that you join us for another session throughout the day and the week. Have a great day.
Thank you.